Okay, Zach, how do I do this? It says find a power series, so that's gonna have letters in it, variables. Hmm? Well, the question says find the power series to represent the function given. This is also in the packet, 9.1 packet. Here's the function, and it's asking you to create the series and state the interval of convergence, meaning what x values will make this really work. So it's like, what's the geometric sum equation? Does that work for anything, or is there some conditions? To be a infinite series that converges, geometric series that converges, what are the conditions that have to be true?
Each term has to be equal.
No, Amelia?
Or has to be the same.
Oh. That's what it is.
That has to be true. So, say this equation that Zach told us and this equation that's given, they're kind of similar, right? So what is the first term of my list gonna be? X. First term is that dude on top. Adrian, what is the R that I'm gonna be multiplying by each time? If I force this on this, so George, what's the next term? Okay, you got us the first one. What is it? To generate the next term, it's first term times R times R times R times R, so what's the next term? Cameron, what's the next one after that?
4x cubed.
Naomi, what's the next one?
Minus x.
Wait. Positive. Yeah, question? Eddie, what would the nth term be, the general term?
I said x n times 2 to the n.
And you don't need to tell what n you chose to start with, but it looks like you started with n is 1. You don't need to say, unless they're like, oh, write this stuff in sigma notation, and then you're gonna need to put that easy. But it did also say, what's the interval of convergence? What x values make this list true? So Nathaniel, what do I have to do to figure that out?
Put 2x in between any one and one on
That has to be true, so, and then dividing all the pieces, not both sides, because there's 3 pieces. So if you pick x equals negative a half, it's not gonna work. But if you pick x equals negative something just a little teeny tiny bigger than negative a half, it will. Questions? Yeah.
Could, with this sigma notation of n equals 0 and then x times 2x to the n, like,
Mm-hmm.
yeah.
So the one that Debbie suggested her n value index would have started at 1. Amelia's would start at n is 0. It's the same thing. Okay? Were there any other issues, questions from the 9.1 packet that we didn't entirely finish and you guys were supposed to do on your own? This one we sort of did. Kyle, what's the derivative of this series?
0, 1, x, and then x squared, and then x to the third.
All the denominators just go away? Multiply by the power, lower the power. That 2 reduces and there's a 1 down there. Multiply by the power, lower the power. What happens then?
Over 2. And then over 3 and then. Or over 6.
Over 3 factorial. The factorial, like this, is going to end up being multiply by the power, lower the power. Gonna be x to the n minus 1 over n minus 1 factorial. Isn't it giving itself back? It is its own derivative. So what do you think this function is? Is. Yep. Okay. I believe your quiz on this stuff says Thursday. It might actually be Friday. I need to check. So we haven't done 9.3 yet. 9.3 is error. Like, if e to the x is too hard to compute, and you just want a quick, what is e to the 5? Is it gonna work for that? Like, is it close enough? How much error tolerance do you have? So that's coming up. Wanted to point out the last page of your 9.2 packet has the common things listed out. I do not want you memorizing most of these. First of all, this one, realize it looks like that and be able to produce the list. First term is 1, the R value is X. Generate it just by starting at 1 and then multiply by that X. This one, force it to look like that pattern and go on with that. These two, I recommend you know them, because AP will ask things like, oh, give me the first 5 terms of that, or give me the 6th degree Taylor series that approximates that. You do not want to do these by the long hand of creating all the derivatives and then integrating up. It just is sneaky. So know these two. And these guys are generated using this pattern as well. Do the derivative of natural log, we get that, which is this series. Integrating up, we end up with that. And tan inverse would be the integral of 1 plus 1 over 1 plus x squared. so we can generate that series and go from there. Do you know what I mean? Should I show it? Yeah.
So you can generate the series like on that and then just integrate each part into it.
Yep, so. First term, times R, times R, times R, times R. And then, oh, I didn't want that, I wanted the integral, and it works. Don't wanna talk about these right now. This is, they have equals on them. That's 9.5, I'll get to those details later. Yeah. And these guys converge for any x that you can think of. And again, that's 9.5, I'll get to it later. All right, today really is meant to, first, and were there any questions with the 9.1 stuff? No? I mean, it's hopefully not terrible.
Page
52. So. This one. If I integrate this. Raise the power, divide by the new power, and divide by the derivative of the stuff inside as chain rule. And it's still squared, I can't do the, it doesn't look like this yet, so I gotta square it on there. All right, if I integrate again, I don't know, g of x. Raise the power, divide by the new power, and divide by the derivative of the stuff inside. Now this looks like okay, so how do I get this guy's series? Well, I'm going to, did the integration to go this way, what do I need to go do the derivative? So the derivative of this and then I need to go one step further and do the derivative again. And the interval of convergence, it's wherever the first one that fit the pattern, what was its R value? When is that less than or less than, strictly absolute value less than 1? Negative 1, 1, and it inherits, yeah.
Is there a way to distribute the first integral, part integral, to get into the form of the Euclidean series, or does that not work? Like distribute the denominator?
If you distribute it all out, it's just a mess.
Okay.
It's I've got my negatives and positives mixed up, but no, it's not gonna be nice. But can you guys try this, just to see that we understand what the others are doing? And be careful, it is not centered at 0. Oh, write some stuff down. Do you need to write this? Absolutely not, but just wanting you to see that it's not different. It's x to the 0, x to the first, x to the second, x to the third, x to the fourth. Why is it not actually just x to the 0? Well, because the center is at 3. So each of these, like I showed the example, when we integrated up, we integrated with x. When it's off center, you're integrating the x minus 3, or x minus the center, whatever that was. Some years it's significant. Questions about that? Yeah.
Isn't the x to the third term the one? Yeah.
Meaning those guys, it would be 4. Like, I could reduce, I don't need to.
Yeah, but, we wouldn't include the last one, right?
Oh, because it says what would be the,
Yeah.
okay. I didn't read my own question. That's the whole entire polynomial. If I just wanted the x to the third, you're right. So just asking x to the third, it is the third derivative, x minus 3 to the 3 over 3 factorial. Sometimes they will ask, what is the term? Just a sec. Sometimes they'll ask, what is the coefficient of? And then that would be -2 is the coefficient. Yes, Amelia?
On a test, can you leave it like how you have it included?
On the AP exam, please leave it like that.
Okay.
Evan?
So I would, kind of try to solve this the way we were doing it before, we do the thing that we're solving for the C. Are we still able to do that even with that center?
Yes, it takes a long time, and, they will force you to understand the relationship of how to use the nth term. They could ask, pick a number.
6.
They might tell you, here is one term in the Taylor series. What is the 6th derivative at 5? You need to know, okay, the pattern of this is the 6th derivative at 5 times x minus 5 to the 6th over 6 factorial. All right, well, the x minus 5 to the 6th cancel, and so whatever 18 times 6 factorial is my answer. So they have ways to make you talk. Yeah.
You divide by
Nope.
Oh, I see.
We're solving that way, yeah. Another, okay. They are so creative. Same things, I changed one number. Not asking for you to find the new polynomial or anything. I'm asking, given this information about the Taylor series or whatever, given this information, is there a maximum, minimum, or neither at 3? Okay, what does it, thinking back to chapter 4, if you need to find maxes and mins, what do? Right?
You get the concavity and the derivative.
So you find the first derivative, and if the first derivative is not 0, no max, no min, but this first derivative is 0. So then you said, look at the second derivative, and what does that tell us?
If it's positive, then
So this says it's concave up. This says there's a horizontal tangent, so there's gonna be a minimum. Yeah. They're creative in how they ask. You really understand what's going on. Ooh. That was one of the old homeworks. Okay, the rest of today, I'd like you guys to have time to work on the 9.2 homework. If you have questions on it, we can go over it, but I don't know that you guys have, gotten that far on things. 17 in particular is challenge. I'm going to cover this up for now, but let you try it. If you want textbooks, they're in the back of the room, but you really ought to spend some time really doing the homework.
I don't think it was either.
I think I wasn't here
Then it would have been
Tuesday and
Yep.
we checked the homework and I think my sister was marked like missing
Oh, I
homework
did.
and so I just want to show you that I did the 2
Okay,
days
okay,
homework.
okay.
Thank you.
Okay, that's what I have. Okay. I don't know, I just didn't think I was right.
Okay.
I am right.
And
then I didn't understand this one was like, only when I couldn't, I didn't even know.
So I did something, I feel like it's very wrong though. 31 I didn't get at all.
Oh, yeah, me too, babe.
And then 19 I struggled with that. But I also, all this is like deeper. I don't know if it's right.
So, in 19, I struggled with PNC.
Yeah, same. I feel like we have like some other things.
Yeah. So like, what, 7, 21, 31, and 19.
Yeah, there's only one. Then I would actually do 3 because I did that one.
I did it. I don't wanna think I did it.
You didn't really get very far.
No. Like, I think I was on the right track. Can we have you done it?
Can I copy down your progress? Like it actually is.
Yeah.
Yeah.
31 is just because you can't do at 0. Sine of 0 divided by 0, like
Oh.
technically it's a discontinuity.
So technically you just can't do it, or?
Right, and so what they would do is like, and you know what, at 0 itself, we're just gonna say this first thing is a 1 and move past it. Like they cheat around things that there's a singularity. So that's all.
So what would you do?
This is just saying, like, the first one they're saying just blindly do the sine x expansion and then divide by x and it comes out, like you can do that.
Oh, so they
And
just,
part-
so they just don't do it like that. Like they just kind of cheat it.
Yeah,
Okay.
yeah. So part B is like technically, because sine of 0 over 0, we can't divide by 0, so it can't be evaluated there, and they're like, just do it anyway, because L'Hopital's rule, we could do the derivatives and it comes out to a number, and
So they're
it was
telling
all,
you
for A, since it's like,
They say just do it.
So basically, you just take like the Taylor series of sine and then
X
divide
minus
it by
X cubed over, yep.
Yeah, and then you divide it by x.
so like you
Okay.
just follow the pattern.
Yep. And so it would be, okay.
That feels so cheaty. I don't like
Yeah,
that.
yeah, I know.
Oh my god, OMG, I wonder where I got my pencil from.
Yeah, see everybody with my pencils nowadays, especially Virginia.
Okay.
That's so good.
Yeah. Okay, whatever they want us to do, it just makes me uncomfortable. I don't like that. I hate that they can just like do that.
Yeah, yeah. So, and,
It's
like,
so they're basically like, oh, just ignore the fact that
It's like
well,
this,
they're
like,
saying,
word.
they're not saying ignore the fact, they're saying you can't technically do.
Oh, and for part B it says it's not quite.
I know, but like,
series.
if you haven't read,
Technically not eligible.
if
Yeah.
you haven't read part B yet, then you're like,
Right, but like, here, once we get to that stage, there's nothing wrong with it.
Yeah.
Like the divide by zeros aren't there anymore, so
Yeah.
it's sort of like, we did L'Hopital's till it wasn't an issue, we did some smushy till it wasn't an issue. I agree with you, it's cheap, but,
It like technically kind of works.
and you need to see some of these things that, well, it's all even, so is it cosine, but the bottoms are odd factorials, so maybe it was really sine. Like, these kinds of questions show up in multiple choice.
like
And
what is
which
the,
one
like
of
the
these
starting
four op-
point?
Which one of these four options could be this?
Okay, yeah.
Okay.
And looking through it, the even powers on the top tip me off it being cosine, however, the odd factorials on the bottom, it's really hard to get factorials.
That are different.
Yeah, so to me it says sine.
Yeah.
What had to happen to sine to make the powers
Divided
go?
by an x.
Or could you also multiply by an x?
So if it was,
Yeah, that would make it just one higher, sort of one lower.
Yeah, exactly.
so that was in the packet.
So it'd be like x to the fourth over 3 factorial instead.
Right.
Okay.
So then again, all of the powers on the top would have become even. But the things underneath were still odd.
Okay.
And how would you write like the n?
This,
Yeah.
well, the negative you want to turn on and off. So let's see, because I want the factorial to be, so I would have my n starting at 1.
Is this for the x sin x?
This
Okay.
one. The way okay, first, x to the 2n, that's the easiest thing, and the underneath is that power, that 2n,
It's like
downward. And then I need to make the negatives turn on and off in the right
And
place,
then
so.
for the sine x, yeah.
That's one.
Um, 2n, and my n is now starting at 0.
Yeah.
So it's 7
And I want negative n, or the first one to be positive, so that works. And n is starting at 0.
Yeah, okay.
Okay.
So anytime basically they give us like sin x or something like kind of almost modified in it, should we just do the like expansion
Like,
for sin x
yeah.
and then like do whatever modification
then-
it is?
For Taylor series stuff?
Okay, yeah.
Sure.
Okay.
Yep.
So like if they gave you like sine x over x to the 7th, you just do the,
They'll do things, but like, the rest of, these are all challenging, icky questions.
yeah, could you go over to me? I literally,
I did something, but I don't know how right it was.
I don't think I looked at that and was, like.
I got just like a really gross like section of derivatives. and
Well, we
that
don't
gave me
need,
really
I
gross-
wrote down the problem.
Yep.
So the square root
Yeah,
stuff,
but-
you have to do the derivatives. Like, there is no nice
Okay,
pattern.
I did that and then I got worried that I was doing it wrong because all the derivatives were really gross. And,
Oh, wait.
Well, but plugging in 0, you get kinda nice
Yeah.
numbers. So that's A. All that work is for A.
Okay. Oh wait, I did the first 5 terms.
And then,
Okay,
and then
I
you,
got that.
and then you integrate that.
Well, no, is this thing an integration of that?
No. But can you
Well,
replace
for-
the x with the like x squared? Okay, that's what I did.
Oh my god.
So replacing the x with the x squared, because I guess I didn't say that.
No, you said that.
Well,
Like the 2x stuff. Wait, how did you see for this one?
See?
but I didn't say it was a thing you could do with all the polynomial series. So I can put 3x in each of those. I can do that with these guys that I generated as well.
And for C, could it, wouldn't it just?
So now C, find the first 4 non-zero terms for this stuff. Okay. So it's saying this list B is the derivative. So integrating, which by the way, this is the thing they want you to use for plus C. So integrating each of those. So that's H prime of X. Integrate, I get some unknown, integrate, we're centered at 0, thank God. X cubed divided by the new power, raised to the power, divided by the new power. And it said, first 4 non-zero terms, 1, 2, 3, that I got by integrating.
And
my
the one
plus C,
given.
And my plus C.
And then you have
Like,
to solve for C.
Well, they give you C.
Oh.
But I show,
But technically, yeah.
I show solving for C, there it
Yeah.
is.
Okay, that makes sense.
It's gross.
Yeah, it is.
It's chapter 9.
What else was there? Number 7. Or 19.
Oh, 7 and 9.
But she explained 31. And it made sense once.
Yeah.
That's what I hate, all of these just like explain it and it makes sense.
But it's just like if I do it alone.
For second, can't you do the A? Well, I forget if
Well, I
the
don't
question
know
was
if I
asking
was
for
asking
power
for that.
series.
So I feel like if it were asking for power series, I would have done
I
it.
feel like that too, but I also could just not really remember.
Or I also could have been like, oh, what's the power series?
Yeah.
I could have proved my name, oh, what is that? Could you go over,
We could do 7.
can you do 7, Ms. Wesco?
Yep.
There's a chance we might have just been
There's a
stupid.
chance that we could have
It's gonna
just
pop up on
done.
the screen and say power
Yeah.
series, where we're like, oh, never mind, you know.
Maybe I just misread it.
So,
Oh my god, it's
I know.
It is
Miss
Pi Day.
Pascal, I like your shirt for Pi Day. I noticed it.
I never got Pi for Pi Day.
We got it. Did we get Mr. Barnes?
No.
this number 7?
Yeah.
Well, what's the,
Is it supposed to be-
question?
Is it supposed to be like a power, like, are we supposed to do it by power series where you just do the A and the R?
Geometric series, yes.
Okay. Never,
Never-
you don't have to
yeah.
go over it then.
We got it then. You're still.
We both did read the question.
Oh wait, no, actually I do need help on this because I don't know
I
how to do the
didn't do
general
it
term.
because I accidentally did 5 instead.
Oh. Yeah, I tried. I tried for so long and it was just like nothing was.
Okay, so we need x to the,
X to the N
Wait,
plus
which one is
3.
this?
Okay. Why wouldn't that work?
Because
Okay.
the first term would be 4, the second term
Oh,
would be
it's
It's increased,
so
No.
how do we go 1, 4, 7,
That would
10?
work.
The second term would then be 2 plus 3, which would be 5.
Okay. Okay, so
right?
if that needs adjusting, cause yeah, what you guys are saying, what, Michael just said, 3n
Plus one.
plus 1, where does n have to start?
0.
Oh. And then do you need the
And then
negative
the
to turn it
negative.
on and off?
And then we need a negative to turn it on and off.
But how would that, oh, never mind, I see.
Yeah, I got you.
I was gonna say, how would that get you,
Like,
4, but then I realized
like,
it's
when you like, when you're running things, it's sticky, someone.
Wait, so if it asks for like whatever number of like non-zero terms, you can do either the Taylor series or the Power series for
Some of them just like
them,
don't.
or like,
So, to do this by Taylor series, it's doing quotient rule.
yeah, I know.
Yeah,
I
that's
looked
where
at
I
it
was
and I thought it was
stuck.
gonna be that. I was like, what?
Like,
I think
oh my god, no. I mean, you can,
But it's
It,
dumb.
yeah.
Yeah.
So if you can do,
Power series.
Power series, do you wanna do Power series?
Yeah.
Okay.
Yeah, so like, to do the geometric is so much easier, and I would not do the derivatives for this guy. I would have cosine memorized, and then just plug in x to the
I
fourth whatever. it is.
Okay.
That especially.
Oh, that's cool.
Yeah, cause I remember I was like, I think it might have been like the context of like, we learned
That's like
something
actually
like
upgrades.
that day and that's all I was thinking about.
Yep.
And
yeah,
so then I was
hear
like,
you.
oh, well.
So, that's why I wanted to show you guys the,
With durable back.
that one.
The derivative and then you integrate it. Okay, yeah.
Wait, and so in theory, if you like for 7, if you did do the Taylor series, which would be gross, would it get you the same answer as the
It
Power
should.
series? Okay.
But I feel like there's so much room for
So they're just,
error.
so there's just 2 different strategies of finding the same series. Just one's normally a lot easier than the
And
other.
right, if
So
you,
this one, the derivatives weren't that bad, and, but this is so.
Yes.
For 7, why would it be an alternating negative?
Why would it? That's right.
Why fold?
R is positive x cubed, so they are all positive.
59
Right.
exact
Okay.
similar one.
But the, like, tangent's absurd, just, the derivative of tangent is secant squared, but the derivative of secant squared is power rule, chain rule, and after the third derivative, it's
It's
just
just like a
massive.
mess.
But-
Like I've tried like, I'm the math teacher, I can do this, I forget it.
but then how would you do tangent
But they wouldn't ask
in
you.
general?
Because you couldn't do Power series.
Because there's
so you'd
no
have to
Power
do
series, there's only Power series for the arc.
Or could you do like sine over cosine and then divide them? Is that a thing you can do or no?
Yeah, actually you can.
Oh.
Oh, okay, tangent doesn't have a nice one, it's just tangent.
Oh, so should we know that?
The tan
No,
inverse one?
the way the tan inverse
Oh, wait, no,
one
that's
is.
tan
do the
inverse.
derivative.
Never mind, I thought it was just tangent.
No.
No, how do you do like tangent though?
Yeah,
Like I get the tan inverse because that's just like the geometric, but
but integrated,
yeah. But I don't like tangent.
Just tangent,
Would they even ask that?
no, it won't.
Okay, so then I'm not even gonna.
There's a chart.
Don't
Yeah.
Don't bother.
It's a special.
And then what? 19 B and
Where's it
C.
getting good? Stupid.
I don't even remember what the question was. I just remember being
That's what it's called.
confused.
Yeah.
You still have to look in that voice?
Like 19A I could do with like.
With like, wait, I just wanna make sure.
So,
Yeah.
the way I did 19A,
Wait,
here's e
you
to the
have
x,
hours.
so e to the x over 2, instead
Oh,
of
okay, I
x,
was-
I'm gonna have x over 2 in each of those. Yeah,
For A?
for A.
Yeah.
Alright. B, like, write the first couple terms of this, okay. Well,
This one was.
Yeah, this one out.
I mean, it did
That's-
something. It did, I just like modified the E, but it was gross.
What?
Oh.
so, and again, this is one of those, at 0,
If you put it-
This is a problem.
A whole bunch of SD code.
Hand wave over that.
Just ignore it, okay.
Yeah, so
probably
to the
wouldn't
x
even
over
see
x.
I would've just done it anyways.
Sorry, should have rewritten it this way, 1 over x times. So this green stuff is e to the x, minus 1 gets rid of that guy,
And then you just.
and then times 1 over x, drops this down 1, drops that down 1.
Oh, okay.
Wait, so the minus one, does it do anything to the, like, any of the other terms, or does it just?
No,
get
I
rid
mean,
of the
this,
minus one? It's
this
just like,
whole green stuff goes in here.
okay, so then you just subtract from the whole green stuff, which is just that one.
And they needed to put that minus 1 in there so that we could now nicely divide by x on each of the other terms.
Still kind of them.
Yeah, convoluted.
I feel like I'm not gonna be like that creative.
Yeah,
on
me
the
neither.
Right,
test.
well, and this is why, like, there's this time in class to
Yeah.
talk about them and go over them.
No, this is
And,
definitely good.
like, question 6 on the AP exam will give you lots of exposure to it before you have to do them. And after a while, you'll be like, I understood what they were asking for 3 of the 4 pieces, so I feel good. You know,
Wait, so on the AP exam, does like, however many like FRQs or whatever there are there like set like topics that each of them are on?
no.
Okay, it's like going in order.
So there's 6 questions, question 1 and 2 are with calculator, and one of those is probably a chapter 10 topic, 50/50 if it's vectors, parametrics, or totals.
Is that just because of like trends from like the past exams, or is that like a thing that they tell you?
That one is just my good guess.
Okay.
Question 6 is always on chapter 9, it's always sequences and sequences.
Okay.
Straight up. There's always a fundamental theorem of calculus, here's a graph,
Do you
what's the
have to do the
derivative?
one?
Oh yeah, oh yeah. Usually question 3 or 4.